Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the concentration of a solution using something called molarity. And before we start learning about molarity, here's a little disclaimer for you. It says that prior knowledge of the topics listed below is essential before watching this video, and I recommend that you first watch the video on writing chemical formulas, calculating molar mass, mole conversion, and SI unit conversion before watching this video. So reacquaint yourself with these four topics before watching this video. So let's start talking about molarity. And first, let's talk about what is molarity. And so what is molarity? Well, it says right here, if we determine the concentration of a solution by comparing the number of moles of solute dissolved in every liter of solution, we would be determining the solution's molarity, or capital M for the abbreviation of molarity. And furthermore, it says the molarity of a solution is equal to the amount of moles of dissolved solute divided by the liters of solution. So let's suppose we have a beaker here, a beaker of water, and what we're going to end up doing is we're going to end up scooping 1.5 moles of sodium chloride into this beaker here and dissolving it. And we're going to end up making a solution of salt water that has a volume of 0.75 liters. How do we calculate the molarity? How would we calculate the molarity of this solution? Well, in order to get the molarity of a solution, we need to know two things. We need to know the number of moles of solute that is dissolved in that solution, and we need to know how many liters of solution we have, or how many liters of solution we're making. And if we want to abbreviate this, molarity is essentially moles per liter, moles of solute divided by liters of solution. And so if we take a look here, how can we calculate the molarity of this example right here? Well, to get the molarity, we need to know the number of moles of solute, which we do know, it's 1.5 moles. 1.5 moles. And we're going to end up dividing this by however many liters of solution we're making, which is 0.75 liters. 0.75 liters. And when we put this in our calculator, we're going to end up with 2.0 moles per liter. And anytime we have this unit right here, moles per liter, we can simply change this to 2.0 capital M. And so, how do we read this right here? Well, we would say we have a 2 molar solution of salt water, or of sodium chloride. So we're going to go ahead and pronounce this with the word molar. We have a 2.0 molar solution of salt water. Okay, so we can use this formula right here to solve all kinds of molarity type of problems, or problems where we're dealing with the concentration of a solution. And so let's go ahead and apply these formula, or this formula and this formula here, which are the same, just this is abbreviated, to 3 different example problems, and hopefully you catch on. In this first example, it says that 12,500 milliliters of a solution of sodium nitrate was prepared by dissolving 275 grams of sodium nitrate in water. Calculate the solution's molarity. So, in order to calculate the molarity of this solution, we need to know two things. We need to know the moles of solute, and we need to know the liters of solution. However, if we take a look at this problem here, we don't know the number of moles of solute, right? We know the number of grams of solute. We know we have 275 grams of sodium nitrate. And so what we're going to have to do is we're going to have to convert these grams of sodium nitrate to moles first. So how can we do that? Well, the very first thing we have to do is pull out our periodic table of elements. And if we do that, we can write the correct chemical formula for sodium nitrate. So let's figure out what that's going to be. Sodium nitrate. We know sodium comes from group 1 and forms 1+ ions. And we know nitrate is one of those polyatomic ions we had to memorize, and it forms -1 or 1- ions. And these two ionic charges add up to 0. So the correct chemical formula for sodium nitrate is going to be NaNO3. And so now what we have to do is figure out the molar mass of NaNO3 using our periodic table of elements. And so if we take a look at NaNO3 and we break this down, we see that this compound is made up of sodium, nitrogen, and oxygen. And if we take a look at our periodic table of elements, we can see that the molar mass of sodium is 22.99. We can see that for nitrogen, the molar mass is 14.01, and for oxygen, on our periodic table, we can see it's 16.00. And we have one sodium atom here in this compound, so we'll multiply by 1. We have one nitrogen, so we'll multiply by 1. And we have 3 oxygens, so we're going to multiply by 3. And so when we put this in our calculator, we're going to end up with 22.99 here, 14.01 here, and 48.00 here. And when we get our calculator out and add up these 3 values, we're going to end up with 85.00. Grams per mole. So here's our molar mass. And so now in step 3, what we're going to do is we're going to convert the grams of sodium nitrate to moles. So we know we have 275 grams of NaNO3 from our problem here. And what we're going to have to do with this is we're going to have to convert it to moles. And so we know that 1 mole of NaNO3 is 85 grams, 85.00 grams. And so when we put this in our calculator, 275 divided by 85.00, we're going to end up with 3.24, it looks like. 3.24 moles of NaNO3. And this is not our final answer. This right here is going to be the number of moles of dissolved solute. So we had to do all this just to get this very first variable here. And so now let's take a look at the liters. Let's take a look at the volume of our solution. It says we have 12,500 milliliters, 12,500 milliliters, but we need to figure out how many liters this is. So we have to use some dimensional analysis here. We're going to cancel out milliliters, so we'll put that on the bottom. We're going to convert to liters, we'll put that on the top. And so we know that there are 1,000 milliliters in 1 liter. And so when we put this in our calculator, we're going to end up with 12.5 liters. And so now we know the number of moles of dissolved particles. We know the number of, or the volume of our solution. We can now calculate the molarity. So 5th step, finally, to get the molarity of our solution, we take moles of solute divided by liters of solution. And so the number of moles of our solute here is 3.24. And we have 12.5 liters of solution. And so we're going to take 3.24 and we're going to divide this by 12.5, and we're going to end up with a molarity of 0.0.260, it looks like 0.260 moles per liter. And what we can do is shorten this down to just 0.260 capital M. So we have a 0.260 molar solution of sodium nitrate. So that's how we're going to solve this problem right here. Let's take a look at another example. In this second example, it says how many grams of calcium chloride must be dissolved in water to make 375 milliliters of a 1.5 molar solution. So if we take a look here, this is a molarity problem. However, there's an issue here. The question says how many grams of calcium chloride must be dissolved. If we take a look at our molarity formula, we don't see anything about grams at all. However, we do see moles. And so if we solve for moles here, what we can do is convert the number of moles after we find it to grams by multiplying by the molar mass of calcium chloride. So hopefully that makes sense, and so let's jump right into this problem. First of all, let's go ahead and manipulate this formula to where we can solve for moles. We know that the molarity of a solution is equal to moles of solute over liters of solution, and we're trying to figure out the number of moles of solute. So we're going to divide both sides by L. If we divide both sides by L, L cancels on the right hand side, and so the formula that we're going to use to solve this problem is going to be moles equaling liters of solution times the molarity of the solution. And so if we take a look, we don't know the liters of solution, but we know the milliliters of solution. And so in step 2, we have to convert this to liters. So we have 375 milliliters of the solution. How do we convert this to liters? Well, we know that there are 1,000 milliliters in 1 liter. This unit now cancels, and what we end up with is 0.375 liters of solution. So now we have our liters of solution. Also, if you take a look, we know the molarity of our solution is right here, so we can go ahead and solve this problem now. Right? So to get the number of moles, like we said right here, we're simply going to take the liters of solution times the molarity. And so we figured out that there's 0.375 liters of this solution, and its molarity is 1.5 moles per liter. And so when we multiply these two together, we're going to end up with 0.56, it looks like 0.56 moles of calcium chloride. And so now what we have to do is we have to convert this to grams. So how do we convert this to grams? To convert moles to grams, we must multiply by the molar mass. So we have to figure out the molar mass. We have to figure out the molar mass of calcium chloride. And before we can figure out the molar mass of calcium chloride, we must first figure out the chemical formula for calcium chloride. So we know that calcium is in group 2, and therefore it forms 2+ ions. We know that chloride is in group 17 and forms 1- ions, or simply Cl-. These two ionic charges don't add up to 0, so we're going to have 2 chloride ions here. And so the correct chemical formula for calcium chloride is CaCl2. And so now if we pull out a periodic table of elements, we can see that calcium and chlorine make up calcium chloride. We can see also from the chemical formula there's 1 calcium and 2 chlorines. And if we take a look at our periodic table of elements, we'll see that the molar mass of calcium is 40.08 grams per mole. If we take a look at our periodic table, we'll see that chlorine has a molar mass of 35.45, and this is going to give us 70.90. And when we add these two values up, when we take 40.08 plus 70.90, we're going to end up with 110.98 grams per mole. All right, so we just figured out the molar mass of calcium chloride. So in our 5th and final step, we're going to take the moles that we figured out of calcium chloride, which is 0.56, and we're going to end up multiplying this by the molar mass of calcium chloride. We know that there are 110.98 grams of calcium chloride per mole. And we'll put our answer down here. So when I take 0.56 times 110.98, we end up with 62.1. And if we're using the correct number of sig figs, we have 3 sig figs here and 2 here. So our final answer should just be 62 grams of calcium chloride that were dissolved in this solution right here. So there's 62 grams of calcium chloride dissolved to make 375 milliliters of 1.5 molar solution of calcium chloride. Let's take a look at another example. In this third and final example, it says a 0.75 molar solution of lithium nitrate was prepared by dissolving 42.5 grams of it in water. We need to determine the volume of the solution. So if we take a look here, we're asked to figure out the volume of the solution. So how can we do that? Well, let's take a look. We know that molarity equals moles of solute divided by liters of solution. And what we're asked to figure out now is liters of solution. And so if we cross multiply here, we can get rid of these fractions. So let's go ahead and cross multiply. We're going to take liters times molarity equaling moles. And now we're asked to solve for L, right? We want to figure out the liters of solution. So we're going to divide both sides by the molarity. Molarity will now cancel. And so to get the liters of solution, we simply take the moles of dissolved solute and divide it by the molarity of the solution. And so if we take a look, what's happening here? Do we know the number of moles? No, we don't. We know the number of grams, right? We know the number of grams of lithium nitrate. So what we first have to do is we have to first figure out what the molar mass of lithium nitrate is. So that way we can convert grams to moles and plug it into right here. So if we take a look, we have lithium nitrate as our solute. So we have to write the correct chemical formula for lithium nitrate so we can get the correct molar mass. And so lithium comes from group 1 on the periodic table, and it forms 1+ ions. Nitrate comes, or it's a polyatomic ion, and so its charge is 1-. These two ionic charges add up to 0. So the correct chemical formula for lithium nitrate is simply LiNO3. And so if we're asked to figure the molar mass of this, let's break it down. There's lithium, there's nitrate, and there's oxygen in this compound. Furthermore, there's only 1 lithium, there's 1 nitrogen, and there's 3 oxygens. Lithium's molar mass, if you take a look on the periodic table, is 6.94. Nitrogen's is 14.01. And oxygen is 16.00. And so we have 6.94 here. We have 14.01 here, and we have 48.00 right here. And if I add all of these numbers up, 6.94 plus 14.01 plus 48.00, we're going to end up with a molar mass of 68.95. 68.95 grams per mole. And so that's our molar mass. And so let's figure out how many moles of lithium nitrate we have. So if we take a look, we have 42.5 grams of lithium nitrate. We're going to convert this to moles. We know that 1 mole of lithium nitrate is 68.95 grams. And so we'll put this in our calculator and we'll put the answer down here since we're running out of room. If we take 42.5 and divide this by 68.95, we're going to end up with a molarity, or I'm sorry, the number of moles of lithium nitrate being 0.616. So this is not our final answer. This is what we must plug into this right here. So let's go ahead and do that now. To get the liters of solution, we take the moles of solute, which we just figured out, and we're going to divide this by the molarity of our solution, which is given in the problem. It's right here. And so the number of moles that we have is 0.616. And we're going to divide this by the molarity, which is 0.75 moles per liter. Remember, this capital M stands for moles per liter. And so when we put this in our calculator, when we take 0.616 and divide this by 0.75, we're going to end up with 0.82, it looks like. 0.82 liters of solution. We have 2 sig figs here, we have 3 here, so our answer must be 2 sig figs. So we have 0.82 liters of solution. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That's going to subscribe you to my channel, and feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.